Hey, Paul.
Hello.
Can you hear us well on your side?
Yes, sir.
All right. And just know that we are at our shop right now, so there might be some big noises. So, okay. So if there is, we might need to take a pause and to go to another place. Just to
That's
notice.
fine. That's
So
fine.
if you can't hear us anymore, just notify and we'll move.
All right. So we are recording. So today we're going to present you our 30K rocket. As you know, we're in the 30K category, the hybrid/liquid category, and we are aiming to do a hybrid rocket. And yeah, today we are going to present you the rocket subsection by subsection. And I guess we could start with okay. So we'll start with aerostructure. So here's our team leads for aerostructure. Hello. So Maxime,
Hello.
Valentin, and Theo Mathieu, that's. So yeah, you can present them. Oh, I just need to connect myself. Okay. Just a few sec. All right, parlez en attendant. I guess so we'll just take our PC for now. So we'll begin with the motor integration. The casing is here, and the thrust is passed to the rocket with the thrust plate. The motor integration with the fin remain to do, but we made the mold, and it will be done this week. So after that, we have the avionic bay, where the avionic will be, and a tank bay in this section. After that, it is a recovery section. We have the drop parachute, the main parachute, and two separation here and here. And this is the nose cone with the payload. This one here. Do you have any question? Yeah, we can dive into more details for each subsystem or integration right now, or if you prefer, we can do the whole, let's say, present the whole system in general, so proportion, payload, and everything.
Yeah, let's present the whole system.
Sorry, I can't hear you very well.
I said, just present the whole rocket,
Okay.
and then we'll
Alright,
have questions
so
after.
now we will proceed to propulsion. Just a few seconds. I just need to authorize some people. All right, so now we'll present the propulsion.
Okay, hello, I'm the propulsion lead, Guillaume. So we'll start with from bottom up. So we have here the graphite nozzle with a composite overwrap. I'll keep it in that pouch because it's to keep out humidity, and for graphite it's better to keep it as dry as possible. But yeah, so that's our graphite nozzle. Then if we go to the casing with the bottom retaining ring here, in aluminum, obviously, with the top retaining ring here also. There was some thread calculations that were done here, so we know it's not going to be an issue. We have the aluminum casing, which has been validated with some calculations for the safety factor, but also during tests, during motor tests, we put some temperature probes over the casing to just see if it reaches value over 150 Celsius, which it doesn't. So keeping on, we have the post-combustion section, which is simply just epoxied wood just to give some like some space for the post combustion and allowing some space in case the assembly is not perfect, so we can just like take off some a millimeter or two just to make it the assembly okay. We also have an example of a fuel grain, which is a paraffin bibar with some black dye to prevent some radiation heating through the grain. We also use for the isolation phenolic carbon phenolic liner. And yeah, an example of it is here. Pretty standard. So yeah, finishing with the combustion chamber, we have the motor head in aluminum also, with some grooves for the O-ring, obviously for sealing. We also have the manifold, which contains the injector, which is inside. Then to connect the tank, the oxidizer tank to the combustion chamber, we have this tubing line. Here we replaced the actual quick connect with some tubing that's the good distance, because quick connect is at our school currently, so we don't have it, but it's a standard. I don't remember the name of the piece, but it's a standard quick connect. Here we have the valve that's going to be remotely actuated. Remotely actuated with the standard handle here. Then finally with the tank, so it's a welded tank that was hydrostatically tested and field tested. So hydrostatically tested at 1.5 FS MIAP and field tested at MIAP. So yeah. Finally, the tubing for the tank. So it's not exactly flight configuration. Normally, we don't have this manometer. It takes too much space and it's useless in the flight configuration. But for the fill configuration, this is what it looks like. For flight configuration, we just remove this part. We have a pressure sensor and a relief valve. Sorry. We also have the bleed valve here. That's normally open and allows us to control pressure if we ever go over MIAP during fill. So yeah, that's it for propulsion. We can go to.
We will move on to payload for now. We have the payload just right here, and it will be Sarah, our payload TV, that will present you the payload.
So this is the payload. Right here, it has a NO2 capture sensor. I mean, so once it is ejected from the rocket at about 115 feet, 100 and sorry, 1,500 feet, the payload will be ejected from the rocket, and then it will take up to 6 NO2 concentration data samples. Yes. So this payload, as I said, is ejectable. So here is the ejection system. So here are some rails, and currently the rails are being reprinted, and it is inserted like this. There's a spring right there that just is activated from distance. So the payload can be ejected from the rocket. Actually, it's going to be the other way because it cannot be ejected for the top of the nose cone. And this is the payload's parachute.
It hasn't been mentioned in the aerostructure department, but on this section there will be shear pins to allow for the separation of the payload and also of the main chute that will be there, and there will also be shear pins at the bottom there to allow for the other separation of the other parachute. We're going to move on with the recovery section.
present the progress. So, I will open the bay. Okay. So, in here was the drop chute, parachute, and at the apogee, we have avionics with altimeter in the nose cone. At the apogee, it will trigger some canister in CO. We don't have the canisters with us. Find them. It's a Raptor. It's a code canister. And this one.
The Raptor canister here.
At 150,000 feet, we have the separation of the nose cone with the main parachute in here. And you have more question or?
The joke is here in its Nomex blanket with its shock cords, and this is our main parachute that also has its two shock cords.
It's a harness there.
Alright, we'll proceed to the avionics system. Nicolas, I don't know if you're ready to present.
Yes, just a second. So this is the avionics module. So it's all the controls of the hybrid motor rocket. So it will be under the tank. And so we have a control for each valve, and we have a radio transmission that we can receive. I don't have the fintenas, which are or custom antennas, but this will be outside of the rocket. Yes, that's mostly that, and we have also a connection to the launch pad to process the fuel, which is the actuator. It's outside of the rocket, so we have also a board that is outside.
Yeah. So that's it, Nico.
Yes.
All right, and just a few notes for the integration of that. Right now it's in wood, but we're currently machining new pieces, new parts in order to do it in aluminum parts and acrylic parts. And I don't know if you want us to present the launch tower. Would that be a good idea or not?
The launch tower, yeah, that'll be fine.
Okay, so was that a yes?
Yes.
All right. So here you have our launch rails. So it's about we have 3 modules, and each module is about 10 feet tall, and they all connect. They all connect together in order to one part. And that big assembly, I don't know if I cannot really get a big overview. Okay, so that's here you have one module part, and after that we would connect those on the base right here. It's not assembled right now. It's not the wood thing. It's the big green thing there. So we use that as a base. And in order to do some counterweight, we use cement plank. I don't know if that's the proper word for it, but you can see that right here. So we put that on our, let's say, launch base, or I don't know, the base of our launch tower, and that allows us to counter the weight. So we've used that last year for our 2 competitions, and honestly, it went well. Yeah, so we'll just reuse the same system as we did last year for our 10K rockets. So I know that that was a really brief introduction to our rocket, but now we can dive into more details for a different subsection if you want.
Well, I have a couple of questions here. So, you don't have fins on this rocket or anything yet?
No, we don't have fins yet. Let's say that there was some, I wouldn't, there was some delay in the manufacturing, but we are planning to manufacture them, let's say on this week. So on Monday, we will probably be doing them, and we have a lot of experience doing the, let's say, integration of those. So it won't take us really long to install the fins on the rocket.
We already cut every ply of the fin, so we just have to do the layup, and it will be in like 1 day. So that's it.
Yeah. And you showed this whole recovery system. You haven't done any recovery checks yet, have you? You haven't done any ground tests, have you?
Yeah, so we are a little bit, let's say, limited in our resources. So we cannot do, let's say, a big drop recovery test.
Well, I'm
So
not
we
worried
haven't
about
done that yet, but
I'm-
we have done a lot of, sorry, what did you say?
I'm not worried about drop tests. I'm wondering if you actually had the
Yeah,
recovery system.
horizontal separation. We've done that. Yeah, we've done that, and it was done successfully. Yeah.
Okay, so we're pretty sure that the CO2 system is going to eject everything.
Yeah,
at
yeah, definitely.
Tu disais que ça a marché avec 30 grammes, mais on a acheté 45.
Ah, okay.
We tested the separation system with 30 grams of CO2, but we are planning to use 45 grams of CO2, so we are sure that it will separate.
Okay, okay. Okay. Let me take a look at some documentation here first.
Yeah.
Sorry, can you repeat the question, please?
No, I'm
Just
I'm
looking
looking
into some documentation.
I'm looking at your third report to see whether there's any other questions I have.
Okay.
Um, So you are going with the 45 size CO2 canisters?
That's
Yeah.
a narrow structures question.
Sorry, what was the question?
Your CO2 canisters for your drogue release. You're still going with the 45, whatever it is, 45 cc's or what? I don't do CO2, so I don't know. 45.
Yeah.
Yeah, we are
Yeah,
planning to go with 45.
Oh, yeah. 45
Okay.
grams.
Yeah, 45 grams. Okay.
Puis
Thank
on a
you.
une redondance avec 60.
And we have a redundancy. We see one canister is 45 grams, and the redundancy is with 60 grams. So we made that to ensure the safe separation.
Okay. Okay. So I might have misheard. So you said you're doing 45, but you're thinking about doing 60 for the backup,
No,
or what?
No. We have
what-
two canister in redundancy. So one the rocket is supposed to separate with one canister, but as a redundancy we had another one. And to improve the redundancy, the canister of the redundancy is 60 grams. So in the rocket we have 145 grams and 160 grams. So it is all made to be sure that the rocket will separate.
Okay, so that's what I said. You're using 45 for a main and 60 for a backup.
Yeah, that's it.
Okay, okay, that clears that up. Okay, let me update. Let me update what I have on my spreadsheet. Okay, and what is releasing your mains?
Black powder.
So you're using black powder. So you have two different sections. You have a drogue section and a main section.
Yeah, we have a bulkhead between both of them. So at the bottom of the section we have the drug, then we have a bulkhead, and on the top of the section we have the main. So we separate at two end of the section.
Okay. How big is your main compartment?
La taille du compartiment.
Et on a stacké.
We don't have the value, but we have tested to stack the whole thing, so we know that it works, as we made tests with the chute inside the section.
Okay, yeah, the chute sits inside, and you've already done an ejection test on that?
Yeah.
Okay,
With all the stuff in.
yeah, and are you still using 5 grams for your primary and 6 for your backup?
Yeah.
Okay. 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 And how are your sections connected together?
We
Different
use
body tubes. How is the body tubes connected together?
we use coupler. So can you bring the computer? We use couplers that are inner tube, which goes between both fuselage like that. Can you see?
Well, I'm trying to make the screen bigger. You're
All right.
you're in one of the you're in one of the okay, let me. Okay, there we go. Okay, so that's typical coupler for all of the sections?
Sorry, what?
Is that a typical coupler for all the sections?
Yeah, that's it. Yeah. So
Okay.
the length of a coupler is 2 times the diameter of the rocket. So that's a 2 caliber size.
Yep. That's a good practice.
Yeah.
Okay. I don't think I have. What electronics are you using for recovery?
For recovery, we are using
Yeah, we use a custom telemega, so we rebuild it. This is our Strad, and our commercial one is a Raven 4.
So you have two. You have a custom one for one, and a Raven for the second.
No, yes.
Okay. Okay. And are both the primary and the backup firing at apogee, or is there a delay?
Une seconde de délai. There, so we have 1 second of delay between both. Sorry. So for the main separation, we have for the main ejection we have my bad. So when we first trigger the first canister, we let 1 second of delay for the second in backup. So the backup will fire 1 second after the first one, the primary one, and it will separate at the apogee for the drug.
Okay, that's for the drogue. The main, you're releasing that at 1,500 feet.
The main will be released at 1,500 feet.
Okay. And the second and the backup will be
1 second later.
Say that again. I'm sorry.
1 second later. So we use time and not feet for the second.
Okay. So 1 second after 1,500 feet. Okay. Breathe in. Okay. I don't have any more questions, I don't think. I think I've got everything figured
All right.
out. If I have any more questions, I'll be sending you an email
Yeah.
here in a little bit. And then we'll then we'll see what the conclusions are after that and see if we can't get you ready to fly. So, okay. Again, good presentation, and I'll probably be in touch with results, as well as I will be sending you a map of the layout of the launch site so that you know how we're going to be doing setups. One other item. Have you already ordered your nitrous?
I mean, we have some in stock, but we will order some more,
Yeah,
let's say, before the competition. But we will order it in Quebec.
Oh, okay. So you're going to be bringing it down.
Yeah, exactly. That's what we've been doing over the past years, and honestly, it works well. However, as we talked about, I think during I don't know, during our last meeting, but the tanks can get a little bit hot. So if we can have ice baths on the launch pad, that would be really great.
Yeah, well, I'm trying to work that out. That's an issue of resources on our end as well.
Mhm.
Working on trying to get it done. There's been a few teams that are excited to see if we can get some way to keep that nitrous at the proper temperature. So we'll see what we can do. Okay.
That
And
would be great. Mhm.
and I'll keep you updated on that. So
Yeah, and also on our side, you mentioned that you would contact us for some results. What are you looking for, and what should we contact you? What should we contact you for?
well, I'm gonna look my data here and everything else, and I'll probably be sending you an email here in about an hour or so.
Okay.
And if I have any more questions, then there'll be questions in that email. If not, then I'll be basically sending you this data and stuff like that. Okay?
Okay, but also just for, let's say, information, we will keep you notice of the let's say the work that will advance, the work that will be done on the rocket, and yeah, we'll keep you updated, and for the fins, for example, and when everything will be done, which will be really soon, we'll let you know, and
Yeah, that would be good. That would be good. Okay. Okay, guys, thank you for the presentation.
thank you very much.
Thanks a lot.
Yeah, we appreciate that, and yeah, we'll keep in touch, and we're happy to see you in New Mexico.
Oh yeah. Okay, guys.
It will be fun.
Yeah.
Bye. Thank you.
All right, thank you very much. Bye. C'est un chien?
T'as plus Pierre est encore là.
Ah, Pierre? Oui. Ben, il est parti.
Pierre est là, check.
Il arrive, il arrive.